Well, howdy, y'all, and welcome to another high-powered episode of the High Voltage Lab Show. I'm your co-host, Willie Snyder with Nat King Code, joined by my excellent hosts over there at the High Voltage Lab Volt Online Academy Studios. They're in Texas, Longhorn Country. Awesome to have you guys with us, and we are joined by a special guest again, Mike Barr. Excellent to have you, sir. Another fellow Coloradoan over here in Mile High Country in Colorado. And we're going to bring you something a little different. We're going to go over on the utility side. So very excited to have you, sir. And you might want to just introduce yourself again, just in case everyone forgot who you were again.
Well, it's great to be with you guys again. I've been looking forward to this all day long. And yeah, Mike Barr. I live in Montrose, Colorado. And we're going to talk a little bit tonight about arc flash and how we deal with it on the utility side versus, where you guys are generally on the utilization side. There's a lot of differences when it comes to arc flash and exposure and how do we protect people on the utility side. And frankly, there's just a tremendous amount of confusion about how we do that with people that have to deal with that. So that's what I'm going to try to do tonight.
Yeah, and I've been part of some of the stuff on that where they've isolated the primary side, and then they'll open up the transformer for like the secondary side, and we'll pull our conductors in. And so even though that primary side's energized, that's locked out, and that's electrically safe work condition on your guys' end. Even though it's energized, it's electrically safe on our end. And so that's where kind of I see the breakdown go when it comes to that. Sorry if I cut you off there, James.
No, that's perfect. Yeah, we'll get into something.
I was just going to say, just from last week, since I knew Mike was going to be on this week, that's why we did the arc flash on the NEC side, we'll say, and to combine them in two back-to-back episodes so people could just sort of tie everything together and see the difference between the two. And that's why we spent time on it last podcast.
Right. Yeah. And it's awesome to be like, kind of the way we organize them is pretty cool. And I kind of got a little bird in my ear about what you're going to do for like your myth and stuff. So that's why I went ahead and put up the CT cabinet picture for my myth of the week. It was a CT cabinet we did, and the utility said, hey, we want a CT meter. We want no more than 270 degrees of bends. It has to be a 1-inch conduit. It has to be bushed at both ends. Has to have a number 6 ground going through it with the bond bushing. And they said, we want it bonded to the neutral. We want it like this. And I was like, well, it's a code violation in our code. He's like, we don't care. We accept the risk, and this is how we want it. And I'm like, okay, I'm not arguing with you. And I did it how they wanted it. So it was a little interesting. In our code book, it would be a violation of ejectable current. So your neutral is bonded at 2 separate places.
All right, let's go ahead and get our meme of the week out of the way, and then we'll go into the myth. How about that?
Yeah, this one. Yeah, so our meme of the week got a lot of attention. I posted around a bunch of the groups and stuff, and it was pretty funny. And I have no problem admitting my apprentice made a valid point, but sometimes it's hard to admit when you got a lot of pride out there. Some guys say they would have drawn 30
cards.
Yeah,
right, 25.
Yeah. So that's pretty funny.
That's funny. I love that meme. That's right. I'll just draw 25 before I say I'm wrong.
Take them right now.
Yeah, exactly.
Last week or the week before, we had one, and it showed a float switch, and the guy had taken a milk jug, and the milk jug was put on. They raised it up and down.
Yeah, it was like a decor switch. It was the off and on.
That was funny. All right, let's
Whatever
get ready
was.
for myth of the week. Looking forward to this one.
It's time for Myth of the Week.
All right, awesome. Yeah, we had a great myth this week. I hit like 44,000, so it's really awesome. We went around to all the different groups, and I was just kind of trying to get some people on this one. I got a lot of people because everyone thought, well, 70E applies to everything energized. Well, that's actually not true. The 70E would only apply up to your service point, and then beyond that would be covered by the utility, safety, and I thought this was a really interesting myth because it's something that a lot of people don't have experience with. Now, if that CT cabinet was customer owned, obviously it would be covered by 70E, but it's not. It's a utility owned equipment. And so then the safety of it would go to the utility. So I got a bunch of you guys that said true. The myth is actually false. 70E does not apply to the utility side of the service. So it was pretty awesome to run it.
And we're going to prove that point here in a second.
Yeah, and so I wasn't trying to be like real trickery on it, but I don't deal with a lot of customer-owned CTs. I think maybe in my career, I think I've only dealt with one out there on the gas plant. All the rest were all utility-owned equipment. So It's pretty awesome. And maybe Mike Barr could jump in on the other side of that and kind of let us know what you're doing.
There's a couple things to look at, of course, is that when it comes to 70E, a lot of people get confused between NFPA 70E and IEEE 1584, where, 70E is a consensus standard that we use for, developing or finding our requirements for people that are exposed and how we protect those. And then 1584 is where we go to get the information we need to calculate the hazard to determine what the incident energy is. And so that's where some of the confusion is. And then, and I'm going to get into this more when I get into my slides, but there's a lot of confusion. I see people, I go into a substation, I'll have a client and I'll go out and do some audits for them. And I'll see a guy standing in a substation hanging grounds on a de-energized bus with a stick in his hands, right? And he'll have a 40-calorie suit on and class 4 gloves. And the impression that I get, and when I start talking to the owners of the substation, they say, well, that's what 70E requires. And so there's just a tremendous amount of confusion about where these standards are separated, right? And they're not separated by voltage. And that's another big myth out there, that there's a low voltage standard and there's a high voltage standard. And that's not correct. All the standards apply to anything 50 volts or greater. It's the equipment is what separates them.
10-4. Yeah, that makes a lot of sense. And we don't typically work on anything that's over 480, but James knows out at Latham Gas Plant, we were working on 13.8 and 4160, just like Terminate. We didn't work on anything energized. It was all in electrically safe work condition. All that stuff was locked out at the gate. And once it was all energized, we were not allowed to touch that ever again. So it's just one of those things.
And that's one reason I put this illustration up here. This comes out of our design book. And basically what we try to show here is the distribution and transmission and the generating plant and everything. And we tell you that that's where the National Electrical Safety Code applies. And then you also need to look at OSHA 1926 subpart V and OSHA 1910 subpart R is where you pick this up. And then once you get over and you get to the facilities, you'll see that the NEC applies there. And then you would look at OSHA 1926 subpart K, and then that's for your construction. And then OSHA 1910 subpart S, and then you got 70E and 70B, that tripod that we talk about. And when you get in and you start looking at this, and we try to, in our books, to make sure you know which standards apply where. And then when you go look at the National Electrical Code and you pick up 90.2B and start looking at the requirements that are there, soon as you get down here and you look at B5, you'll start to see that it talks about installations under exclusive control electrical utility. Then it gives you A, B, C, D. But basically what they're telling you here is these are items that are not covered. But I do want to point one other thing out. When you go over and look at the 70E standard and you pick up B4 here, let me go back one, you'll see it's almost exactly identical word for word.
That's correct.
And the reason I like to point that out is because in essence, what they're telling you here is that the 70E applies to an let me say again, NFPA 70E applies to an NEC installed installation.
Correct.
Right.
Okay. And that's why utility, and said you'll go look at your IEEE 1584 and then you'll calculate, and that's a whole different situation over there than what we're requiring in 70E, because 70E is also used with 70B as it relates to what? Maintenance, based on a NEC compliant installation, which is by the NEC. You see what I'm saying? So looking at that goes without saying at that point, just based on what we looked at here, that 70E does not apply to utility. Okay.
That's correct.
Yeah, and I just wanted to take a minute to give a big shout out to the NEC for Dummies and Daniel for joining, Billy for joining, Tobias for joining, Nick and Charles for joining. Really awesome to have you guys in the house, and it's just really cool to be bringing you guys these kind of different topics that nobody has really done before, and that's what we're trying to do. So hope you guys enjoy.
I haven't really seen anybody come in and show back to back where you do the arc flash for 70E and then do the arc flash for the utilities and show the variances in the two and where it applies and what doesn't apply.
I definitely know they don't have as much. We definitely have way more metal than anybody, for sure.
Of course. You got a question there?
Yeah, I have seen OSHA through their general duty clause, 53A of the 1970 Act. I've seen them go in and recommend through that, like if you're doing that, Mac, you and I talked about this, where they use an informational transfer. And where the utility says that a company is interacting with another company, and they're not just letting the hired contractor do all their supervision too. I saw where OSHA went in and used the general duty clause statement there in section 53A, and they used 70E 110.7 for documentation, and said their meeting should have been documented and all the hazards discussed so that the people wouldn't be getting hurt working in a certain area. Then I've seen them also for the unqualified do the same thing and move from 1910.269 over in 1910.331 through 335 for unqualified.
Right.
I've seen them.
Well,
so you can't.
yeah.
I don't think you should say that 70E never never applies because OSHA under certain conditions can use 70E for abatement. And I think, Mike, you were in on one of them deals in Oklahoma City, wasn't you, with fire zone?
Yes. But you're right. They can use, now if the bottom line
looks like we got somebody agreeing with you there, Senior.
We've got yes, OSHA through the general duty clause can obviously use other consensus standards as a way to abate, right? And the bottom line is whether the standard, whether one standard covers this area or that area, the bottom line is what we're trying to do is protect people, right? We're trying to establish a program or a system that's going to protect the person when they are exposed to a hazard. And there are some times where one standard may have better or more specific requirements for a certain situation. Now, it's just like you mentioned, James. You got an OSHA guy who writes a citation, and he uses 70E because he's talking about this information transfer, right? And he's saying, guys, if you'd have gone over and used the requirement out of NFPA 70E, that is a little bit more specific than 1910-269. 1910-269 says that you have to transfer information to a subcontractor. If you hire somebody, you're the host. If there's information they need to protect their employees that they can't get without your input, you have to give it to them, right? Now, 269 stops right there. It doesn't say you have to document the meeting. Now, NFPA 70E, they chose to go beyond that and say the meeting, you got to hold a meeting and you got to document it, right? Now, all that OSHA guy is saying is
welcome, Andrew. Sorry to interrupt. Welcome, Andrew, from OKC.
You're fine.
OKC
So,
in the house.
All that OSHA guy is saying that under the general duty clause, right? He's referencing another consensus standard that's essentially saying, okay, this is what we want you to do from now on. You know, he can't specifically cite you for not doing that because it's not an OSHA requirement. He has to use the general duty clause. And he's just giving you
their appendix.
Correct.
When you look at their appendix in 1910.269, they reference 70E to the user of 1910.269 for further information. And the only thing I'm saying, we should say to the people that NFPA 70E would never be applicable, that OSHA couldn't use it if they could use the general duty clause.
That's a valid point. That is a valid point. That it doesn't mean, when we say it doesn't apply, it doesn't mean that it can't be applicable, if that makes sense.
Yeah, that's what I'm saying.
Yeah.
And you're right. They can't go to 70E without going through that general duty clause.
That is correct. That's correct. And like I said, just because we say something doesn't apply doesn't mean it's not applicable. There are sections of 70E that very well may be applicable. And if you were to adopt that and do it, then that could enhance the safety of that crew or that individual. Yeah. So
then this one guy, I think somebody had a question about OSHA didn't write citations. Yeah, they can write citations going through 1910.269 or going through subpart S if there happens to be a violation of safety where a company did not do as they were supposed to have done, and it's a violation, then they could write a citation.
Correct.
Right.
Correct.
I wanted to give a shout out to thanks for Anna joining, Lewis joining, Nick, Craig. awesome to have you guys in. I know a lot of people are probably coming over from the Mike Holt live stream recording today. So pretty awesome to have all y'all in the house tonight. So sorry to interrupt you guys.
We ready to do topic of the week then? Has anybody got any other questions? So basically in essence, we would look if there's something that exceeds what the requirements are in 269, it would be perfectly logical to take and apply something in 70E.
Yeah, and look at the appendixes and the annexes to those standards or the part you're looking at, because they will recommend these other standards to be used. Just like they recommend 70E, then when you go to 70E, at 200.1, it refers you to 70B for maintenance, and that's how they go through the back door to get to some of these standards. And then if you look at 70B, the IEEE standards for maintenance on equipment says use 70B. So there is a loop that you go through in the 4 main standards, and you can check it out. NEC, OSHA drives it. 70B, OSHA drives it. And also drive the NEC. So there are 4 standards there that 3 really that they drive, OSHA drives, but you got to use all of them to loop them together, or you can get very confused using these standards.
Yeah,
Well, good
you're
information.
absolutely right. And again, you got to use what's applicable. You know, it just like I said, just because it doesn't specifically apply, certainly doesn't mean it's not applicable. Yeah, definitely. Good point.
Let's say one thing to you listeners. Listen to old Mike Barr, because he's very knowledgeable on the supply side. I'll tell you that for sure.
Yeah, he is.
Awesome. Cool. Let's roll the topic, sir.
Topic of the week. Let's do topic of the week and let him get started. Okay, Mike, I'm going to share the screen for you. And
Okay.
let you take off, brother.
All right. Okay. So I've got a lot of slides here, and I'm not sure how deep we want to go with this. What I'd really like, the way these things work for me the best is as I start going through this, guys, if you got any questions that you have, I think that's, you know, if we get some discussion going on this, I think that's the best way to approach it. But because there is a lot of information here, and I just don't know that we have the time to get too far out in the weeds with this. But like you had mentioned before, James, you know, that if you take a look at the system, obviously you've got your generating facility and then you're going out to a substation and your T line, and then you go to your distribution and you get to your customers, and you know, as I said, we're not separating these standards by voltage. It's the equipment. It's where you're at in that system where you know, subpart S and subpart K apply, and where subpart R and subpart B apply. So, and tonight, of course, we're just going to be talking about 1910-269 and the requirements for protecting people from arc flash. You know, we didn't have really anything in 269 or subpart B to really do anything to protect this from arc flash as far as specific regulatory requirements on the supply side until 2015. And that's when these standards were revised. Prior to that, the only thing we had in subpart V or in 269 was it just told us that we couldn't wear clothing that when exposed to dangerous electric heating and arcing, that it would contribute to the burn. And of course, we always took that as meaning, polyester synthetic clothing. So in 2015, that changed, and we got some very specific requirements for the protection of employees from arc flash. So I'm just going to kind of run through these real quick. But
yeah, Mike,
remember,
and if any questions come through, they'll pop up on the screen, so you'll just see them pop up down below.
Perfect.
If they come through. That way I don't interrupt
Perfect.
you.
Yeah. So like we talked before, guys, subpart S, you look at the exclusions, work on or directly associated with installations of utilization equipment used for, generation, transmission, or distribution installations. They're exempt, right? It doesn't fall under subpart S per se. So, and then once you get over into 70E and you start looking at the introduction to 70E, it uses language that talks about how it's important to understand that, we're talking subpart S and 70E apply only to the employees' workplaces that are, basically we're talking premise wiring. And work on the line side or the service point is the responsibility of the utility. And 331 through 335 and 70E does not apply. Now, what they do is in the introduction to 70E, it says that except for unqualified. Okay, so in other words, when you're working under 269 subpart B, you're a qualified employee. Those rules only apply to qualified individuals. If you're unqualified, then you shouldn't be doing the work, of course. And then 70E saying if you're unqualified, then you're not exempt. It's kind of a weird deal, but they throw that in there. So and then of course, when we're talking about safety rules for the supply side, we go to ANSI C2 and then of course 269 in subpart B. Now another thing that you got to point out here is that when you talk about utilities and the exemption to the utilities, they make it very clear that OSHA considers equivalent generation, transmission, or distribution of industrial locations to basically their utility company. So in other words, if I got a big company and I generate my own power, and I've got my own substations, and I've got my own distribution and even T-line, you're considered a utility as far as regulations are concerned. So it doesn't matter if you're owned by a utility or not. If you have equivalent installations, then you're effectively a utility company.
All right, that makes sense.
Yeah. I mean, obviously, you got to put that equipment somewhere, right?
Yes, sir.
So it's the same equipment that the utility has, and so of course it falls under that. So I'm not going to get into a lot of discussion here on what 70 or 269 and how it covers this. We know that it covers what we're talking about. Subpart B, of course, is just the construction side. And when it comes to the topic that we're talking about tonight, the arc flash requirements, they're exactly the same in subpart B as they are in 1910-269. So
yeah, and I'm really glad that they have a standard for the unqualified side as well as me. That's awesome.
Yeah, exactly. So so these are the standards that apply when it comes to dealing with arc rated clothing and how we protect people. So let's just kind of run through real quick here on what it is that 70E requires. There's some really specific differences when we're dealing with NFPA 70E and we're dealing with 1910-269 and how they address the hazard. There's some really big differences on how it's determined and how it's calculated. And there are some really significant differences too when it comes to clothing, and particularly face shields and protecting a person's head and face. There's some very specific differences when it comes to 1910-269. But basically what OSHA requires a company to do is you got to assess the workplace, and you got to identify any employees that might be exposed to arc flash. Okay, so now the way that most companies that I'm dealing with work with this is they just assume everybody is, even the guy sitting in the office that might go out and go into a substation to do an inspection. Okay, they make the assumption that he is exposed to an arc. That's how a lot of utilities, a lot of these guys are handling it. They're just saying, you know what, we're going to put everybody in arc flash clothing. And I'm not saying that's a bad thing. It's not required, of course, to put everybody in arc flash clothing, but that's the way a lot of companies are handling it. And I got no issues with that if that's what they want to spend their money on. And we'll talk more about this in a bit.
So, question for you, Mike: is there on the utility side, is there a lot more justified energized work than there is on our side, so to speak, on the 70E side?
Yes, absolutely. Because on your side, guys, you're not allowed to do energized work, right?
Right.
OSHA says you have to de-energize everything unless you can justify working it energized. It's got to be either more dangerous to turn it off, or it's got to be infeasible. Otherwise, you got to turn it off.
Right.
We don't have that requirement on the utility side.
Gotcha.
Because we have to work everything hot, right? Well, we don't have to, but it's a very common practice, of course, for us to work energized.
Tempor.
Not only on distribution, but especially transmission. A lot of hot work done.
Gotcha.
We don't have the requirement on this on the supply side to turn things off. So, but we're required to go out and assess who it is that's exposed, right? And it doesn't, that it's not requiring you to identify everybody by name, right? Just, you've got certain groups or certain crafts in your company, of course, that you can just make the assumption that by the nature of their work, they're going to be exposed. And then there's going to be employees with your company that are, based on their job descriptions and what they're tasked to do, that they would never be exposed to an arc flash. So it's really easy to classify these people according to the standard. So now what they do, they make it really clear here that it only applies to work that is performed on or near exposed energized parts. So employees that do not need to conduct, they don't need to assess the tasks and whether or not someone's exposed if they're not working near exposed energized parts. Okay. And what does it mean to be near it? So and they tell us what that means, of course. Basically what that means is if you are going to work at MAD or closer, then you're going to be exposed. If you're outside of MAD distance, then OSHA doesn't consider you exposed, unless you're doing something that could violate the MAD. So they make it real clear that it's just the employees that are going to be working at MAD distance or closer, okay, or doing switching or something else that could cause that arc flash, okay. Again, you don't need to identify by name. They talk about normal operation of equipment. Now, you guys remember, this is something that was adopted in NFPA 70E, a couple code cycles ago, where it talks about normal operation of equipment.
Yep.
They talk about the same thing here in 1910-269. And they basically say that if you install and maintain equipment and there's no evidence of impending failure, the risk of electric arc is low, then OSHA says there's no exposure to an arc hazard.
And just to clarify for everyone watching, I've ran into this before. If you go up and one of the bolts is glowing, that's not normal operating.
Or if there's smoke coming out, if the factory smoke has gotten out, then
the genie's getting out of her bottle.
Yeah. So, and this last bullet here, guys, I pulled this right out of the preamble. OSHA considers the risk equivalent to turning off the lights, right? Now I don't. They're just saying, normal operation, okay, and people have to determine from themselves what normal operation is, and you guys know as well as I do that most companies default to some level of clothing, no matter what. So
and especially I think that goes into, like, if you're firing up a gear for like the first time, then it hasn't actually fired up, then you got to dress and make sure you're being careful on that stuff.
Correct. And then people do.
I don't mean to interrupt you.
Go ahead.
70E does define what normal operation is.
It does.
They put that in. Yeah.
Yeah. And this is OSHA's. This is the James. This is this is all that 269 says about it. Is if it's properly installed and it's maintained and there's no evidence of impending failure, then that's normal operation. Yeah, you're right. Yes. 70 gets into a lot more detail.
Yeah, I just pointing that out. I'm sorry.
No, you're fine. No, don't worry about it at all. More input, the better. Okay. So there again, whenever the risk of the arc is higher than normal, then OSHA considers that, and they use the example of like racking in a breaker, because, when we rack in a breaker, of course, that's not normal operation anymore. Evidence the equipment, it's kind of along the same lines as 70E when it comes to normal operation. So, and I don't think we need to spend a lot of time talking about that. So, but here's a good example. I'll walk into, I'll go do audits, and I've got clients that I'll go out and I'll see, and you'll see somebody opening a switch. Now, this is a fairly low profile switch, of course, and I'll see this guy standing there, and they'll put him in a 40-calorie suit, be down in South Texas and in a substation, and the heat index is 118 degrees, and there's a guy opening the switch, and he's got a 40-calorie suit on. And that's the kind of things that I'm seeing on the supply side. There is so much confusion about what that guy is required to wear. And if you start at the base, baseline, and you're following 1910-269, and that switch has been installed properly, and there's no reason to believe there's a failure, there would be no arc flash clothing required for that guy, unless the incident energy is above 2 calories, right? Now, NFPA 70E uses 1.2 calories. 1910-269 has a 2-calorie boundary. So there's a little bit of difference there, and I can explain why that is. Basically, what happened is when 1910-269 started to develop this revision, at the time, if you guys remember, and James, I know you remember this, that the 70E standard allowed anyone working under the exposure of 2 calories to wear cotton clothing. And of course, it's been a little while ago they changed that. They took that out, and they went to 1.2 calories. So when OSHA was writing their standard, that was the way 70E was still written. So they adopted that. And then, of course, by the standard got out, NFPA 70E had changed it. And OSHA just said, screw it, we're staying with the 2 calories. So if this person is standing on that mat and he's opening this switch and he's outside that 2 calorie boundary, he would not be required to wear arc flash clothing. Now, this is where it gets a little tricky with 1910-269, saying, okay, he may be outside that 2 calorie boundary, and so he's not exposed to an arc flash. However, if there's a switch failure and there's molten, there's all this molten material, this vaporized and melted material that could shower down on him, it could ignite his clothing. So they say in that case, he would need flame resistant clothing. And this gets a little confusing because 1910-269 says sometimes a guy he might need flame resistant clothing, but he doesn't need arc resistant clothing. Okay. So, and obviously the easiest way to work your way through that is you don't put anybody in flame resistant clothing, because flame resistant isn't arc resistant, but arc resistant is flame resistant. So that's one of the things about this standard that's a little bit, they'll say under certain circumstances, yeah, you're going to be outside that 2 calorie boundary. You don't need arc flash clothing, but you do need flame resistant clothing. And it's so a little confused. Yeah, go ahead.
Let me ask you a question. So does just a standard like long sleeve FR, like say you just got a jumpsuit with like the lowest FR rating, does that have any calorie rating?
FR has no arc rating. No.
Okay.
FR does not have an arc rating. No. It's only to protect you against flame. It's not to protect you against arc. If it doesn't have an ATPB, if your garment doesn't have that ATPB number on it, it's either going to give you the actual calories or it's going to give you the category. And if that's not on that shirt, then it's probably FR. It's not AR. So,
gotcha. Okay.
Yeah. It'll have 2 ratings. It'll be the ATPV or the EBT, and that's both of them are based on that Stowe curve.
Correct. And that's going to be on it somewhere, definitely. So, yeah. So now, another thing that OSHA looks at is there a probability that an arc flash can occur? 70E does that too. We've got table, 130-15, and anyway, I can't, but we've got a table that in 70E that basically says, if you're doing this, then there is a likelihood of an arc flash. Okay. Well, 269 kind of gives us the same thing. It's a little less, it's not in table form, but it basically just says that if you've got an employee, he may be exposed to an arc if in his work area, if the probability is higher than it is for normal operation, and they give you these factors to look at. If I've got energized parts that are not guarded, and there could be some type of conductive object that could fall into it, that would increase, obviously, the risk of an arc flash. If I've got energized parts and the employee is closer to the part than the minimum approach distance, then I got to have arc flash clothing on. Okay. Now, again, that MAD distance is really critical. In other words, basically what they're saying, guys, if I can walk around a substation all day, and if I'm not operating a switch, and I'm not going to be in a JLG, or I'm not going to be up in the air in any way violating or even close to that mag distance, there's no arc flash exposure. And I have people all the time say, well, Mike, what if you're in a substation and a transformer just blows up? Well, holy shit.
Right.
You should have bought a lottery ticket that day.
Yeah.
OSHA doesn't expect us to protect people against that. That's not a work hazard, right? That's and transformers don't fail like that anyway. So
Right.
now I'm not implying, I'm not trying to tell people that they shouldn't have arc flash clothing on when they're in a substation. That's for each company to determine on their own. I'm just saying that from a regulatory standpoint, there is no requirement for me to have arc flash clothing on just because I'm in a substation.
Right.
That would be like on you guys' side, on the utilization side, requiring someone to put a 40 calorie suit on just because he's in a switchgear room, right? And
Yeah.
not switching anything, he's just walking through it.
Right.
So it's kind of the same thing.
I agree.
So yeah, and then of course, when there's evidence of impending failure and so forth. So as you read these regs, what you're finding is that it's pretty clear that OSHA is looking at work, right? We're looking at and it's no different than when you're on the utilization side, guys. If you're not working on stuff, if you're not interacting with the equipment, there's no arc flash hazard, right?
Yep.
But gosh, I'm seeing stuff out there that's just driving me nuts. Just because, my good friend Clint here is standing out here in a substation, right? 20 feet, 25 feet below a substation bus, wandering around this yard, in no way is he exposed to an arc flash hazard, right? And
Right.
the rules don't apply to that unless, of course, I'm working. I'm doing something that could cause that arc flash.
Well,
So-
another question for you, Mike. Would you say that when people are trying to be like way too safe, do you think that's actually causing like an additional hazard, possibly?
That's hard to say. People have to judge. Now, when I go down to Corpus Christi in August, and I see someone in a 40 calorie suit with class 4 gloves on, with a hot stick in their hand, hanging grounds on a de-energized bus, yes, I personally believe that is there's first of all, there's no possible way that this guy's going to be involved in an arc flash.
Right.
In order to have an arc flash, it's got to be energized, right?
I agree.
There has to be a source, and so there's no reason to put them in that to begin with. And then when you've got a heat index that it's 118 degrees, and these guys are hanging 12 sets of grounds because they got to hang one on every feeder on both sides of that bus. Excuse me. They're in that suit for a while. So yes, I would say so.
Right.
You just gotta, people have to, the problem is, guys, is that what I see out there, people are trying to meet a regulation rather than try to protect you against a hazard, right? People are getting too lazy when it comes to arc flash, in my opinion, especially on the utility side. All they're doing is throwing clothing out there, and they don't even know what the hell the exposure is. They're just putting you in clothing, and that's what frustrates me. So
I would agree with that. Sorry to interrupt.
No, you're not interrupting at all. So this is just a chart that OSHA uses. It's same stuff we just talked about, whether or not you're exposed to a flame or arc. and if I'm doing normal operation, if I'm servicing equipment, racking in breakers, and so forth, if I'm inspecting electrical equipment, I'm holding a conductive object, but or I'm not, and I remain outside the mad distance, no arc flash hazard. So, excuse me, again, it's just a matter of what the task is. Okay.
Right. I agree.
So, how do you know what you're exposed to on the utility side? On the supply side, we perform calculations. We go to 1584, and you determine, we got to know our short circuit current. We got to know clearing times. We have to know, are we, what size is the box? Now we got to determine, electrode configuration. There's 1584 has been revised, so there's a lot more data that we have to have. It's not as complicated on the utility side. So, but we have to make what's called a reasonable estimate of what these people are going to be exposed to. And there are a couple of ways to do it. Just as there is in 70E, we have tables, or we can have it calculated. The difference is on, we've got some tables in 269. It's the same tables that are in NCC 2, and it's the same tables that are in subpart B. The tables are extremely accurate. They're very, very accurate. They really do everything that you need to do when it comes to determining a person's exposure. So the tables, while 70E, they have their tables too, but tables are tough to follow on the other side. There's too many things that the parameters that you have to stick to are a little bit more restrictive when it comes to 70E versus the utility side. So, yeah. So, one thing here, remember we talked about the 2-calorie boundary. And so what OSHA expects us to do on the utility side is we need to determine where that 2-calorie boundary is. Okay. And if you are going to be within that 2-calorie within that 2-calorie boundary, then you got to wear clothing that is equal to or greater than whatever that incident energy is inside that boundary.
Right.
Now, what they also tell us is, and we'll talk about this later, is, if you're out there on a distribution line and let's say you've got a 2-calorie boundary calculated that is 15 inches. You got a 15-inch boundary, 2-calorie boundary. But I'm on the end of a 8-foot hot stick. Then OSHA says in that case, I do not have to have arc flash clothing on. Now, again, I'm not saying you wouldn't put it on, but if you look at the baseline and you look at the requirement, you only are required to put that on if you're going to be inside that 2-calorie boundary.
Well, from the sounds of it, it sounds like even the office people have 2-calorie on.
They do. That's the point I'll make here later, is that a lot of this is mute because they're just putting it on everybody, right?
Gotcha.
So,
okay.
Yeah. So, and then of course it talks about how even though I'm outside the boundary, I could still get burnt from fluid from transformers, grounding conductors melting, hot debris from faulted equipment. And then OSHA requires flame resistant clothing in these scenarios. So it's kind of weird the way they write this stuff, guys. They're saying, yeah, if you're working up here, you got to have the arc flash clothing on. If you're outside that, you could still catch on fire. So you need flame resistant clothing on. And it's just nonsense to try to manage 2 different types of clothing, of course. So you're going to wear, your arc flash clothing.
Gotcha.
Now, here's where it gets a little bit sticky. Okay. As you guys know, on you guys' side, on the utilization side, we use 1584, IEEE 1584 to, that's where we get our equations to calculate the incident energy. Okay.
Right.
On the utility side, the voltages and the fact that most arc flash on the utility side is considered a single phase event, it's extremely rare, and it's very difficult to have a 3-phase event,
Right.
even on a distribution line, and certainly not on transmission. And because of the spacing of the conductors and the way that we typically will cover conductor when we're working on distribution, we use line hose, we use blankets, and so the likelihood that you'll have a 3-phase event is extremely low. Okay, so it's typically considered a single phase event.
Gotcha.
Okay, so I'm going to jump ahead here a bit. When you're working on the overhead lines, right, it's again typically going to expose you to a single phase arc in open air. So now, if you guys remember, IEEE 1584, what are the voltage ranges for that? 208 up to 15 kV. Okay.
Right.
And it's also only for 3-phase. 1584, the equations consider everything a 3-phase event. Okay.
Right.
So if I use 1584 to calculate that incident energy on an overhead line, right, the number that I come up with, the incident energy that I come up with, is going to be extremely conservative. It's going to be way beyond typically what my actual exposure would be.
Now, can you take that number and divide that by 3 to get a single phase event?
No.
Okay.
There's the method that we use. Okay, so here's the table, and there's what this table indicates is that they basically recognize 4 different methods for calculating arc flash or incident energy. You've got your NFPA 70E, NXD, right? Which are the Lee equations. I think you guys are familiar with the Lee equations. They are theoretical. This is not empirical data. It's not, and they're extremely conservative. If you use the Lee equations to calculate incident energy on the utility side, you're going to have numbers you won't be able to work with them. You're going to have guys up there in 30 calorie clothing, so you can't use the Lee equation. The Doherty, Neal, Floyd, same thing. It's not a these they haven't been modeled in a lab, right? So you got to go. There's only 2 that have, and that's IEEE 1584, of course. Right. And that one is limited again to 3-phase only and 208 up to 15 kV. Okay, so you have to be, and then the only other option we have is ArcPro. Okay, ArcPro is a program that it's a company up in Canada, and they have a software package that you can purchase, and and this is data. These are equations that have been verified in a lab. This is empirical, not theoretical equations. And so OSHA recognizes ArcPro as the best system for calculating incident energy on the utility side. Okay.
Gotcha.
The problem the difference is here, of course, 1584, I can purchase that standard. I got access to all those calculations. Arc Pro, everything they have. So in order to use it, you have to purchase it. You have to buy their software.
Gotcha.
You have to buy their software. Okay. So anyway, this is just some notes to the table that talks about how, given phase separation, this practice, 3-phase arcs in open air, it's very unlikely for that to happen. So,
yeah, and it seems like that's the concept behind what we run out in the plant. It was called an NGR, neutral ground resistor. And then that's basically only set up for like a single phase event, like a energized conductor to ground versus energized conductor line to line.
Right. Yeah. Now you may get an arc or a fault across 2 phases, but that's still considered single phase.
Right.
But it's really not likely to ever have a 3-phase event in open air on a line or a bus in open air. So
yeah, and they even say a line to line is pretty rare.
It is, but it certainly is more likely, but a 3-phase, yeah. So what OSHA tells us, of course, is that Arc Pro is intended for single phase. Now, Arc Pro, if you do want to calculate 3-phase with Arc Pro, you can do that. They used to provide us a table to convert single phase, but I think the new software will do that for you if you choose to do that. So
Gotcha.
you can do that if you want to. Okay.
Nice.
So all right. So that's the table you would use. Now I get a lot of questions about this, guys. What about somebody working in a vault? If I'm down in that vault and I've got a transformer, and I've got some pictures of this type of event, and it's not good. It's, people think that the arc flash down there is actually going to be worse, and it really isn't. I mean, it's worse because it's all contained, right?
Uh-huh.
And you've got other things to deal with. You've got, of course, the containment and the wall of the enclosure is going to reflect that heat. And you've got burning oil, and it's just a really bad place to be. And so I get asked all the time, well, if I do my calculation and I've only got 8 calories of exposure down there, should I put a 40-calorie suit on? Well, you could, but it's still only going to be 8 calories. It's 8 calories, 8 calories. You got all these other things to deal with. Right. It's just a real shitty place to be, right? It's just not somewhere that we should be doing energized work. So, and basically OSHA, what they're saying here is that you're still going to estimate the heat the same way. There is no other method other than, like I said, it's going to be 8 calories is 8 calories, 20 calories is 20 calories. It's just going to be a much worse event. And it's just not a good place to be.
Yeah, okay. Tempor. Want to give a big shout out to Dave DeLima for joining. Appreciate you jumping in, sir. Go ahead. Sorry for interrupting.
Okay. So real quick here, we'll go through the table. I'll kind of give you an example of these tables. We don't need to spend a lot of time on this, guys. And then we can maybe, start talking with some questions or whatnot. But this really is the easiest way to do this. Okay. So what they've given us here is, and guys, I've got a good friend who has the Arc Pro software, and so I've run these numbers, and damn, these things are close. They really are. They're very accurate. But there's a couple of notes to the table that you really have to pay attention to. So let's say that someone is working on an overhead line. We got 12,470, right? And let's say that our fault current on that line is 10 kA, okay, 10,000 amps, and I've got a clearing time of a maximum clearing time of 9 cycles. Okay, so if I go and I've got 10,000 amps of fault current and I've got 9 cycles of clearing time, where do I fall? That tells me that I'm in a 4 calorie. The maximum exposure I'm going to have is 4 calories.
Right.
Okay. So now the thing that you got to keep in mind here is that this table, the distances that were used, the working distance that was used to determine these numbers is 15 inches. Okay. Because the assumption is that someone could be gloving that, right? And if I'm gloving something, and you can glove up to 36, nobody does it, right? But you can. I shouldn't say nobody does it. But if I'm gloving something, even at 12,470, let's drop it down where it might be more likely to do some gloving work. So let's say if you go to 4.0 up to 15 kV, I've got 10,000 amps of fault current, and I've got a clearing time of 18 cycles. Guys, that's a long clearing time.
Yeah, it is.
So I've got a 4 calorie system. Now, the working distance that they use again is 15 inches, because that's the assumption where you would be if you were gloving. But if I'm on the end of a hot stick, right, and I'm 8 feet away from it, not 15 inches, what's my, am I going to be less than 4 calories? Of course you are, because the incident energy is inversely proportional to the distance squared. So if I've got a 4 calorie exposure at 15 inches and I'm on the end of a hot stick at 8 feet, hell, I'm not even going to be exposed to an arc flash. So, and again, I'm not saying you wouldn't have arc flash clothing on, but you have to take these tables and understand that when you're up to 36 kV, these numbers were all done based on a 15-inch exposure, right?
Wow, and that's really different, because I think most of our common circuit breakers trip at about a half a cycle on our side.
Well, obviously, if I'm on a distribution line, it depends on how that line is fused and how that recloser might be set. Depends on where you're at. Some of these lines are fused, and these reclosers are set so that you give that branch time to burn off, or you give that squirrel or that raccoon time to burn, and so it just depends on how that line's fused. But
gotcha.
Yeah, so you look at these, and these are long clearing times, and that's what I'm saying. The likelihood that it's going to be 18 cycles is pretty low, but they're just using some maximums here, and so you can see that up to 36 kV, the worst exposure that you're going to have is 12 calories. Okay?
Right.
12 calories.
And
so
that's due to it being open air, correct?
Correct.
Okay.
It's due to it being open air, and it's also based on fault current and obviously current time, open air, distance. But yes, open air is a big difference. It's a lot different than me standing in 18 inches in front of a panel board.
Absolutely, I agree.
So
that's a lot of grounded parts. A lot of grounded parts in there too.
Exactly. So, and then guys, if you go up to the higher voltages, right? It's the same thing. Your fault current's going up, and then you've got some clearing times, and you'll see that again about 12 calories is as big as it gets, right? Now, the difference here is obviously our working distances are going to change because we're not going to be gloving any of this. All this is going to be done with working with stick, right?
Right.
We're not going to be 15 inches away here. So the distance that they use for this table is the mad distance minus 2 times the arc distance. Okay, so if you take a mad distance, let's say that you got a mad distance of 5 feet, right? And then you subtract from that 5 feet 2 times the arc distance. The arc distance is 1 inch for every 10,000 volts.
Right.
And that's to build a little bit of a safety factor in there. So,
Okay.
the point I'm making here is, guys, that when I'm working up at these higher T line, when I'm on a T line and I'm working on a stick, I'm typically going to be way outside that minimum approach distance.
Right.
And then I'm going to subtract 2 times the arcing distance from that number. So I guess the point I'm trying to make here, guys, is that arc flash on the utility side is really much less of a risk than it is on the supply side, or I'm sorry, the utilization. The utility side is less than it is because of the distances and the open air, and there's just a lot of different things that make it not as hazardous.
Gotcha. And just hold tight in the chat. We're going to go through some comments here once Mike gets done. So just letting you guys know, I'm not ignoring you. I'll post them up there here in a minute.
I got one more thing here that I want to point out. And of course, one thing too, guys, we don't need to label anything on the utility side. We don't use labels.
Wow.
There's no labels that we're not going to go out and label substations, and how do you label stuff?
Right.
What you do is you determine what the highest risk is, and you protect people from that. But you don't label anything. Okay.
Oh, okay. That's good info.
Yeah. So this is just an example of the Arc Pro program that I ran the other day. You go over here and you put your current in, how long it's going to take, put your arc gap in, which is your arcing distance. This is on 138 kV. Your source voltage, because you're only doing single phase, not 3 phase, is 80,000 volts, right? So,
wow.
So once you punch these numbers in, I can go over here and I can find that my 2-calorie boundary is somewhere between 5 and or 10 and 15 inches, right? So it's going to be here between 10 and 5 inches. So probably about 7 inches, somewhere in there. And I can play around with it and get the exact number, but that's where my 2-calorie boundary is. So think about this, guys.
Wow.
My 2-calorie boundary on 138 kV, let's just say it's 10 inches, right? That's where my 2-calorie boundary is on 138 kV based on the fault current that I used here, which this is an actual scenario that I calculated for one of my clients. But
Nice.
So who's going to be 10 inches away from 138 kV?
That's
we're not going to work that close to it. We're going to be 8 feet away from it, 6, 7, 8 feet away, if we're sticking it, or even if we're climbing a pole, So the point I'm making here is that you just don't see arc flash incidents on T-line. You will see them on distribution. You will see people because but a lot of times it's a contact injury. It's where somebody actually makes contact. So anyway, that's just an example.
Well, and it makes a lot of sense because it looks like you could mitigate that risk by disconnecting at like the gate where you're out in open air, and then your electrically safe work condition over in the actual gear side.
Correct.
Where you have the more risk, and you're mitigating that hazard by ensuring electrically safe work condition, using the lower risk with
Correct.
the open air.
Yep.
Makes sense.
Correct. Yeah. So again, the further you are away, just like it is with any arc flash, you get further away from it, it's safer. And the way to do that is, of course, with the stick. So
Nice.
One last thing here that I wanted to talk about. What's the level of incident energy that we are required to use a face shield when we're on the utilization side? When we're working on you guys' side, where do I have to start putting that face shield on? What incident energy requires me to put a face shield on?
Is it 50 volts or more?
No. What incident energy?
Oh, okay. Incident energy. 2 calorie.
1.2. Right?
Okay.
Right, James?
Okay. He's muted over there.
Oh, okay. So now, obviously on the utility side, especially on distribution, this became a big problem to overcome, because think about putting a lineman in a face shield with a balaclava on, up in a bucket, doing line work in Houston, Texas in August.
Right.
Very difficult, right?
Yes, sir.
So when you start looking at what they did here for face protection, they had to look at a couple of things. And that was one of the things that they looked at, was how are we going to put these guys in face shields, right? But then they started to study things, and they started to look at things. There was a lot of testing done, and one thing that they determined was that the arc flash protection is usually always based on the energy level at the person's face and body, of course, at the working distance, not on the hands and the arms, right?
Okay, gotcha.
Same thing on the 70E side. We're no, I shouldn't say it like that. We're not as concerned about the hands and the arms as we are the face and the body. Okay.
Right.
The head and the body are a large percentage, right? And so they took some of that into account. Let me get to where I'm. Okay. So, but what they determined also was that an arc flash in open air for a lineman is a little bit different than, and of course, you standing in front of a panel board.
Yes,
because
sir.
When I'm up in a bucket, a lot of times when I'm working, I'm working with my hands up, the exposure is above me. Right. And so when that arc occurs, of course, it's going to dissipate in a 360-degree sphere, and the heat's going to travel up, and the distance from my face to that arc at an angle, being downward, is longer than it would be if I'm straight across from it.
Yep.
And so they determined that they were going to cut us a little slack on face shields. And they also determined that the face, even if I got third-degree burns on my face, if the rest of my body was protected with arc flash clothing, I would survive that. And so what they're trying to do is make everything survivable. And you read some of this in the preamble, and they basically are saying, you know what? you might have to sacrifice your face.
Right.
And so what they came up with, and it's more complicated than what I'm trying to get across here, but if I'm exposed single phase open air, which you would be on a distribution line, then I'm not required to wear a face shield until I exceed 8 calories.
Okay, gotcha.
Yeah.
Wow.
And if you've determined it's a 3-phase event, then it's 4 calories. But typically it's going to be that single phase open air. So I'm not required to put a face shield on the utility side until I exceed 8 calories.
Oh wow. Okay, that's interesting.
So
Yeah, didn't know that.
And then
for sure.
if it gets up above 12, then you got to put the hood or a face shield in a balaclava. Now, another thing they tell us about the face shield, 1910-269 allows you to exceed the rating of the face shield by 4 calories. Okay, so in other words, if I've got a face shield on and it's only rated for 12 calories, I can wear that if the exposure is up to no greater than 16.
Okay.
So they'll give us a little bit of a because these face shields are only rated for 12 calories.
Right.
So, but they will allow us to wear it up to 16. And now another thing, guys, that I want to point out here, I get into a lot of discussions with people about whether I got to have rubber gloves on with leather protectors if I got a stick in my hand. And of course, you do not. You are not required to wear rubber gloves when you're utilizing a hot stick, as long as your hands are outside the minimum approach distance.
Right.
So now, if there's an arc flash hazard, what OSHA says is that I'm allowed to wear a pair of heavy-duty leather gloves as long as the exposure to my hands is less than 14 calories.
Okay.
So,
wow.
So I can just put on a pair of leather gloves. And now, if you want to put on hot gloves with leather protectors, have at it. But I can use just heavy-duty leather gloves, and there's a weight rating. I can't remember what the weight is, but I can just wear leather gloves with that stick. I don't need to put.
Well, and that's kind of cool because it goes to show you can exceed that minimum safety standard, but you can't go beneath it.
Yes.
Like you can't go less than the standard. You could always go more.
Oh yeah, absolutely. Yeah, you can always do more. Right. So
awesome.
Okay,
yeah, that's awesome.
That's all I had. I could go on a lot longer, but I think we've touched on the most important parts.
Okay, so we had a comment come in about your one where you said there was an incident in a vault, and I believe this is John Aries, one of our followers. I think he's a top fan on my Nat King code. But he's saying back in '89 there was a tragic accident where they opened the wrong vault, thinking that they had it shut off. Or
this happens, guys. There was one up in Seattle area a few years ago with I won't tell you the company, but a company that I used to work for, one of their units, and there were some guys in a manhole and they were pulling elbows. I can't remember specifically what the issue was, but it's just horrific. It's just a bad place to be.
And he was actually making a comment to the California, licensing for like qualified people and stuff, and
right,
certifications, and that's kind of a big thing. I just took the NISAT test for fire alarm, and they extensively mention the definition of qualified person in fire alarm. Must be qualified in testing, must be qualified in inspection, And so if you're not qualified in testing and inspection, then you're not a qualified person to work on fire alarm. But no, that was an awesome presentation. Everyone loved it. We spiked up. We had the most viewers on here we've ever had. So appreciate everyone joining us.
One thing I want to mention before you guys, before we're done here, you mentioned qualified and unqualified. And people try to make a big deal out of that. And it is a big deal. Don't get me wrong here. But, I've been doing this a long time. I'm not as long as James Sr., but I've been there, a long time. And I can tell you guys, every incident, every accident, every fatality, every amputation, everything that I've investigated over my 50 years, it's been a qualified person.
Yeah,
these are qualified people.
Yeah.
But it's people that get complacent and gosh damn it, they just take shortcuts. And I don't know what it is about our industry and why people, I don't know. I don't want to get on my soapbox here, but I wish I could figure it out, because then I could retire. But
I agree.
It's just too much. It's just too much of it.
Yeah, and welcome for joining. Welcome, Chris Doherty just joined. Awesome to see you in the chat, see you in the house. So appreciate you guys all for joining tonight. Really awesome to have such a big audience in here. And like I say, everyone kept asking me, they're like, hey, what's the requirements on the utility side? I was like, watch our show on Thursday, you'll find out. So that's pretty cool. It's a really awesome presentation. And I always learn every time you come on. I like your little thing that you did last time. He has the little testing, like how to properly ground your system, and that was awesome. When you're going on there and it would beep, and you're like, "Oh, you just had a dead lineman," and that was pretty cool. I liked how that thing worked. As I learned a lot even the last time too. So
good. Appreciate that.
Pretty enjoyable.
Yeah, we were sitting there. I noticed some of them tables. Those are in the yellow OSHA book that you supplied to us.
Yeah, they're in the yellow book. Yeah.
I was like, I remember seeing that. One of them I did. Dad goes, "It's in there."
Yeah,
I said, "Okay."
they're in there. Yeah, they're in there. Yeah.
Well, did we want to roll the tool and
awesome? All right, well,
get us all finished out?
We got to do the 5 changes first.
Enjoy it,
5 changes. I almost forgot.
See you guys.
Yeah, thank you, sir.
All right, we'll see you next time. What do we want to do next time?
Later, brother.
We'll figure it out.
I'll give you a shout and discuss it.
Okay. Talk to you guys later. See you, James.
Take care, Mike. Later. Let me get all set up here.
Yeah, I forgot about the changes. I know we're already blasting the changes.
Well, let me go ahead and cue it up, and we'll cover the 5 changes.
All right. Big dogs are in the house.
Looking at this, what I ran into here was, let me go ahead and get this queued up here. All right. Now, what we're going to look at this week, you're just going to see a lot of more changes than anything. It wasn't something that's new in the code. It's more of the way they laid everything out. Like as we look here at 430.52C1, when you start looking at this, these used to be exceptions. Okay.
Right.
This is now going to be full code text. And the next one we're going to look at will be table 430.52C1. It won't be just table 430.52 anymore. So
Right.
Everybody's going to have to get used to what is taking place here. Now, one of the things I want to point out is you're going to see where it starts. It says, unless otherwise permitted in C1A or B. Okay. Now, when we used to look at this was exception 1, exception 2. And what it says is still the same thing. The heading still says in accordance with table 430.52C1. And we've had this discussion on I think it's Jeremy telling me I didn't know what I was talking about, but it says it specifically says a protected device that has a rating or setting not exceeding the value calculated according to the values given in table 430.52C1. Now, that stayed exactly as it was. And basically what that means, once you perform the calculation based on the percentages over in table 430.52C1, if I can't exceed it, that means I can do what? Drop down. Okay. And that is a starting point. Now, something I want to point out for people watching this, we'll look over in a minute and you're going to see table 430.52C1. It's going to say maximum. Okay. That's the maximum for that table. Okay. It's not the maximum overall. And what I like to point out here is in our design book, Journeyman, Masters, all of them that we have, we go in and discuss this. We start this as our minimum point, even though the table says maximum. And then we would go to the exception, and then exception number 1. Well, now it's 430.52C1A, and it basically says without doing any further calculation, if the motor won't start to the inrush current, then I'm automatically allowed to go up to the next standard size. Okay, so to give y'all an example of this, let's say that I had a motor, and let's say the motor was we'll say it's a 460 volt, 3-phase, 50 horsepower, design B motor, and we're going to size like an inverse time circuit breaker, just a regular breaker. All right. Now, if I go over and I start my calculations, I'll just do it off the top of my head here. If I have a 50 horsepower motor at 460 volts at 65 amps, when we go over and look at the table for sizing an inverse time circuit breaker for a squirrel cage motor design big at 250%, that'll give me 162.5 amps. The next size below that's 150 amp overcurrent device. Done. Okay. Now that doesn't mean I can't go lower. That's just a starting point. Okay.
Right.
Then if you look at A, without doing any other further calculation, I could go up to 175 amp. Now, if I look at B, it even allows me to go up to what we call the maximum size at this point. And it says, if I have a full load current of 100 amps or less, and the motor was rated at 65 amps, I could take that at 400% per B3 right there. So if I take 65 amps at 400%, that's 260 amps. It says I can't, once again, exceed that calculated load. So the next size below that would be a 250 amp. Okay.
Right.
That, and all of that is no longer an exception. It's full code text telling you they realize this happens out in the field. It's not something that's really an exception. It's something that we do on a continuous basis. Therefore, it's full code text now. Okay.
Nice. Okay.
Now,
that's
the
cool.
next one that I'm going to get into.
I solved that argument.
Mm-hmm. Yeah, I mean, it's pretty self-explanatory. You know, the argument he gave, and which I didn't agree with, he said, oh, well, the table says maximum. Therefore, if you don't match up to a standard size, then you automatically go up to the next size. But yet in the same sentence, he turned around and said, I can go lower than that. I'm like, what are you doing? Picking and choosing where you want to apply the certain language. If you go back and read it, specifically says not to exceed the calculated value. That means I can do what? Drop down. So, you know, if I have 162.5 amps, I don't match up. You automatically tell me I have to go up to a 175. No, that's not what it's saying. Okay.
And if that motor fires up and runs at 150, then run it.
That's right. And
You
and
know,
that's what I'm
that's
saying.
good.
To make that kind of statement, he's wrong. Now, here, there was no change here. All they did here was line this up with 430.52C1. Instead of it saying table 430.52, this table will now be labeled table 430.52C1. Okay. So what's going to happen here in all of our publications, because we're one of the few that do this, is we take in all of our illustrations, we have all the sections, the loops and everything. We're going to have to go back and change every bit of this. Okay. So everybody's going to have to get reacquainted once again with all the new section numbers. All right. Now, the next one is 430.52C3, and you're going to see this is where we're going to deal with an instantaneous trip circuit breaker, and they're going to have a new one there for A, for application, and then you got B, your settings, and you're going to see it's the same information here. The only difference is these are no longer exceptions. They have been placed into full code text once again. Okay. So it's
Which
just,
that kind of makes it better, because you don't have to worry about all these exceptions. You just
that's right. I've always advocated that it should be full code text because it's being applied all the time.
I
So
would agree with that.
this here is just clarifying these sections here and putting them in full code text. That's all they're doing. And all they did is renumber it like they did 430.52C1. This is now going to be 250.52C3A and B. That's all they did. Okay. Now,
Right.
the next one that they did here is they took where you're dealing with several motors or loads that are on one branch circuit, and we're dealing with the smallest rated motor that's being protected. All they did was take this, and now instead of just a big paragraph, now all of this has been placed into a list format. So you're going to have to get used to looking at the list format now. So all that's going to be relabeled. Matter of fact, most of this 5 changes, this is what it's dealing with is how they took everything and put them in list formats. And if you look here, they did the same thing. They just added 430.53C1 through C5 and just put everything once again in a list format. That's it.
Gotcha.
Okay. So
yeah, that's pretty simple.
And what I'm trying to tell people when they look at all of this is you're going to have to start getting familiar with a lot, because if you notice all the changes a lot of the changes we've gone through, there's been a lot of renumbering of the tables. Stuff has been placed in a lot of list formats now. So a lot of the section numbers, a matter of fact, some tables have even been moved. They're not even in the same section anymore. So you're going to have to get familiar, relearning once again, where all of these calculation and list formats are now placed, because it's like Article 220, how much of that got renumbered? They moved stuff all around in there.
It basically says the same stuff that it did before, just in different
That's
spots.
right. It's all different spots. And what we did, there'll probably be a lot of the other code change publications out there. They're probably not going to cover a lot of this stuff, but it's important that you cover it, because people are going to start looking for this stuff and want to know where it's located at, because it's moved. And if you're used to one section to go look at, you're going to have to refamiliarize yourself with everything. Okay.
I agree.
And those there, my brother, are the easiest 5 changes I've done on here.
Yeah, absolutely. No, it's really awesome that you're doing this, and I think a lot of people can go back and what they'll probably do is they'll probably go back, watch all our episodes, check out all our changes, and realize you gypped them on 20 changes, and then we'll have to go back and then do some extra changes. But I don't know, like once you get Colorado, I might figure out if maybe you could just add in 20 changes to the Colorado program, and we call it even or whatever, but no, I really appreciate all your learning that you do. And, I like how you show like the first draft and the second draft in there, and the like substantiations and everything. It's so awesome. Like you're like one of the most thorough code changes that I've ever witnessed. Like when I actually took my Colorado for 2020, I just was like blown away how much I just actually learned. And I'm sitting there telling the inspector, "Oh yeah, they did that because they don't want 2 grays in the circuit, you know what I mean, or whatever, that they're way different voltages, So it was really cool, and that was awesome.
This next one that's coming out is even going up another notch because I'm in chapter 3 right now, but I'm taking the first revision and second revision substantiations from the code making panel, showing how what their substantiation was to that change. And then we correlate everything with the illustration at the end. Plus, at the first, we put the new 2023 NEC text and everything's highlighted in yellow. So it is really, to me, that's probably the most thorough code change, especially online course I've ever seen. So we're putting all the extra time in, and matter of fact, come Monday, the new website will be up and running, everything. I mean, we're getting ready for 2023. So
nice, dude. That's awesome, man. I can't wait. And we'll get some more substantiations in there on some stuff and get really rolling for 2023. I'm real excited, and I can't wait till you get the states going, because I got so many people asking me about Colorado.
I'm getting everything up and running now. It's a long process because there's so many changes that have been made and the things that we're doing that it's really going to take off once it gets going. And it's already doing good. But I mean, once I get all the states and I get especially when I finish the generator, transformer, motor, compressor, man, we're going to have all kinds of courses on there. It's going to be, we'll have more courses than any other provider. I'll put it that way. So,
well, I was really awesome too to get Pops in on here and let me know that I was correct in calling it a CT bonding conductor rather than a supply side jumper on the utility side, So that was pretty awesome,
Ted Fritz doesn't know what he's talking about. I didn't even get in on that conversation. I remember you asked me that. I said, I don't know where he got that from. I said, but that's just completely wrong. But don't worry, we'll get called some more names. I ain't worried about it.
It's all good, man. I ain't scared.
All right, let's do your tool of the week, brother.
All right.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
All right. So this one, I'm going to try to switch off with like Milwaukee and DeWalt every week. This is one that just recently saw on the job site, and they say it's like the new atomic line that DeWalt has, and it looks pretty awesome. It's compact. They said it can cut up to 1.5 inch pipe, I think they said, which is pretty big. I mean, 1.25 inch would work for that. So if you're running a bunch of 1.25 inch, that thing would fly. And it's really light. It's compact. One of the guys at the job I'm working at said it was real easy to get up in the ceiling and cut what we needed. He didn't like mine, which is a little tiny bit bigger, but mine can cut 2 inch. So, like I say, sometimes you got to run 2 inch, and you can't use this one with 2 inch, which would be a downfall. But overall, I like the DeWalt battery life. I don't think you're going to find any cordless tool out there that can compete with the DeWalt battery life. And the thing that's nice about the DeWalt is that they have a really good 1-year warranty on, like, when you buy it brand new. And I've never had to use a DeWalt warranty yet. So they're pretty good. Like I say, one of my guys dropped a DeWalt and dropped it from like 10 foot and took it in there, and they gave him a new one. So I was impressed. I was like, there's no way they're replacing that drill. And they did. So it was pretty cool to like I say, everyone calls him Yellow Decker. You know, like I say, there's a lot of negatives that you could look at any different brand, but I'm a tool guy. I like all tools, and so we're going to be bouncing back and forth and giving our reviews between DeWalt and Milwaukee. And I really want to get one of these and try it out and see how it works for just running a bunch of small conduit and stuff. Seems like it should work good.
Awesome. All right.
Yeah. So I'll post it up on the tool page, and anybody checks out, we got the electricians only tool review, and I try to post my reviews up on there and, you know, go over them and talk about different things, you know, so it's really awesome.
Well, your friend Jeremy, I thought he didn't watch anything we did. We were irrelevant and lost all reputation and everything, but he's on here watching.
In. Yeah, so I think wasn't a senior saying that was covered. Where was that at that he was saying?
You need to go look at Section 9 in the National Electrical Safety Code, Jeremy, and you'll learn something about bonding on the utility side. And those are the sections that you go look at, and you'll know the difference between the utility side and know the difference where it applies on the NEC side.
Yeah, Joseph. So I'm going to switch off every week. So 1 week I'll do Milwaukee. I might not do Milwaukee DeWalt every week, but I'll switch off. Like if I do a DeWalt 1 week, the next week I'll do a Milwaukee. So I switch back and forth. I don't have a problem with red. Like I say, I use a lot of red tools at work and stuff. Almost all of our KO stuff's Milwaukee, and we have a lot of our big tools. That's
he's just busting on you.
yeah, it's cool. But yeah, it's pretty awesome to, you know, get this out there, and, you know, a lot of these myths, and I guess we're gonna have a new myth about the supply side bonding jumper inside a CT meter, you know, a CT can, you know, but it's pretty awesome. One of the ones I wanted to do was like working stuff energizes out of code violation, stuff like that. You know, like a lot of people say, "Oh, I'm a tough guy because I work on stuff energized." Like, yeah, well, you might be violating the code. So we're gonna look into that stuff and kind of try to bring you guys a lot of really cool topics as we move forward. So awesome show, James. I had a great time.
Mike was awesome. You know, I noticed a lot of people didn't. One of the things that I liked is him explaining the difference between FR and arc rated. And a lot of people there, I could tell some of them didn't realize that there was a difference in that. And when you look at the 70E document, we explained that. And I thought Mike did a great job explaining that. And
yeah, I'll tell you what,
distances and stuff like that.
I honestly thought that FR was the same, like that all you needed was FR clothing. So I mean, and that would be true if you were outside if you're in the limited approach boundary, or if you're in that, you know, different boundaries, that might be true. But when you're in that restricted approach boundary at 70E, it's got to be arc rated.
Yep. So, those are the things you get into, knowing, you know, you get inside that arc flash boundary. Arc rated, brother. That's it.
Yeah, I appreciate you joining me, Joseph. I saw Joseph over in the Mike Holt live stream earlier. It's pretty awesome just to have all these code guys coming on, learn from them, and learn all this different cool stuff, and have fun doing it. Yeah,
I really enjoy doing also the utility side. I think it helps out a lot. People knowing the difference between the two. What has he got? There's a great YouTube video on generating about 2 years ago. Just on the state of YouTube. Oh yeah, okay. I saw that. Yeah. I know what he's talking about. And it was freaking cold. I'm here in Texas. I will tell you, it was cold. And I hate cold weather. I freaking hate it.
That's the whole reason James became an inspector, because it was cold.
It was cold. It was cold up in here. Man, I tell you, it.
I still love the one where everyone's like, "Hey, James, what's a motor?"
A motor. You never seen them. It's a Greek motor. You didn't know that? Trying to teach y'all something.
Oh man, we have a great time doing this. I got the sprinkler guys always coming in here busting on me. It's so funny.
Sometimes you get talking so fast you're thinking of something else and it comes out wrong. I couldn't even believe a motor.
That was so funny. Oh
Hey,
man, awesome!
I was trying
Awesome
to add
show.
a little bit of slapstick comedy to the show. All right.
Yeah, dude. There's some of them you don't even catch when I like ask you questions, and I'm like, "Hey, is that 2-phase or single phase?" And you're like, "Oh, it's single phase." I'm like, "Okay."
It's
So I
two-phase.
was sitting there. I ran across that one. Somebody was like, "What the hell? You talking about 2-phase?" I'm like, "What? I was talking about 2-phase." And then it was like I asked you a question, and I was like, "Oh, I was joking about that." It's so funny because some guys they say single phase is 2-phase because you have an A leg and a B leg, and they say that's A phase and B phase, so it's 2-phase.
Mm-hmm.
And we're like, "No, you're talking about it wrong." But in actuality, in like Canada, places in like Canada, they're actually right because they take a 3-phase transformer and they grab 2 of the phases for the house. So it's like single phase 208, and technically it is 2-phase. You'll have like a like a black phase and a red phase, and those are actually phases of a 3-phase transformer. Right. But we still call it 3-phase, or we still call it single phase because that's how the equipment operates.
Right. Yeah. It's called single phase equipment.
Yeah.
All right, brother. We better wrap it up. We're going on close to 2 hours here pretty quick. So
thanks everyone for joining. I appreciate it. We had a great time. We'll try to bring the heat next week and have something even better.
Oh yeah, we'll have something. Anyway, Mike already got off. Mike, you'll see the end of it. Thanks, brother. I'll get in touch with him. We're gonna have him on weekly. I think he loves coming on here. What is this?
Oh, the EV. Yeah, I remember you were talking about that on Mike's thing.
Oh, okay. Oh, hey, you know, it was funny the other night. Somebody was asking me. He said, "What do you think about electric vehicles and or getting in the climate change?" I said, well, first of all, I said, I don't care anything about electrical vehicles. I'm never driving one. And I said, first and foremost, when the batteries go out, it costs you $40,000-$50,000 to replace it. And I said, furthermore, I'm not going to get the kind of mileage. I said, I don't want to be having to charge all the time because I like to drive around a lot. And as you know, you talk to me on the phone and I'm just driving around just clearing my head because, I just want to get out of the office, or the house because I'm working all the time. And I'll just go get me a route or a quick trip 44-ounce iced tea, and I just go for a ride. And hell, sometimes I even do deliveries just to give me something to do, And
and what did we realize about electrical vehicles? Electrical vehicle charging equipment doesn't connect to an outlet and isn't defined as an outlet. That was freaking awesome. That was a cool myth we busted.
I just can't believe that. That's not right. Everything's a freaking outlet. Everything's an outlet, and it just magically exists too. It's in an infinite location on the circuit somewhere.
It really just writes itself.
It oh, you could get in trouble for that. That's my line, brother.
Oh man. All right, awesome show. Thanks for all joining us. And remember, make every day an easy day.
Amen.
Peace.
Everybody have a good weekend. We'll see y'all next Thursday.